in this video, I want to show you this example where we have to transform an complex number from standard form to polar form, which we can also think of as a trig form. So guys, let us start working on the steps for this one. The very first thing would be to identify my a and b, which is identifying the real part and the imaginary part. Guys, obviously here we can clearly see that the real part a is 1 and the imaginary part is that invisible 1, which is going to be the coefficient in front of the I. And sorry, it is not just 1, there's a negative with it, guys. It's going to be -1. Okay, so this is my real and the imaginary part. This is real part, this is imaginary part. Guys, I can also write this as a coordinate pair 1 and -1. Then what I'm going to do is I'm going to plot this point, right? So this is my real axis, this is my imaginary axis. Plotting this point means plotting 1 and -1. 1 on the real axis means I have to go right from the origin, 1 unit to the right. Let us say this is 1 here, go 1 units to the right. -1 on the imaginary axis means I am going down, right? 1 unit. So let us say this is my going down 1 unit. So this is going to be my complex number z equals to 1 minus I. You can also think of that as 1 and -1, coordinate pair 1 and -1. Guys, since I want a polar form, the trig form, so what I'm going to do is we are going to connect these 2 points, the origin and the complex number, and then you already know we drop a perpendicular in this case, and then we call this angle theta as a reference angle. Now keep in mind this is 1, and guys this is -1, right? This is -1, although keep in mind the distance is not -1, but this is like how we identify the coordinate these points, right? And guys, keep in mind the other thing that we have to make sure is that in order to write the polar form we need the angle. And guys, the angle is usually measured from the reference side, this being the reference side, and we like to measure the angle. The standard way of measuring the angle is from the reference side, and we go counterclockwise, not clockwise, counterclockwise. So that means the angle that we are actually going to call theta is this whole angle from here up to here, right? So this is going to be my theta. Guys, let us not call this theta here because I don't want you to get confused, but it is basically for calculations, we kind of think of that as theta. If you have already gone through those basic ideas of evaluating or solving for the sine functions for any angles, we can think of that angle as theta, but basically this whole angle from this reference side all the way up to the terminal side is my angle theta. Now going back to the definition of the sine and cosine. Guys, what is the sine of theta for this particular setup right here? And guys, this is something that you are already expected to know from the basic sections of evaluating the trig ratios for any angles, and especially angles which are greater than 90 degrees. So sine theta we know is the ratio of the y over, it is y over r, or when we think only in terms of the right triangle, it is opposite over the hypotenuse, but we think in terms of the circle, right? We think it is or in terms of the coordinate pairs, it is the y coordinate over the r. Guys, I have the y, I have the x, but guys, r. So first of all, we should go ahead and find out the r, which is the absolute value or the hypotenuse. We know we can easily do that by using the Pythagorean theorem. R squared is 1 square plus -1 square. So r will be square root of that. So that's 1 plus 1, which is, so r will be square root of 2. So r is square root of 2. Once I find that out, I'm going to put it back and write it out in my figure, okay? So guys, I have my x, which is 1. I have my y, which is -1, and my r, which is radical 2. I like to kind of write those down so that once I have to substitute them, it is easy for me to do that. Guys, y is -1. Please be careful with the sign. The signs are going to be important here. If we mess up the signs, then we're going to get a completely different value, okay? So it's -1 and r is radical 2. But guys, we know we don't like radicals in the denominator, so one has to rationalize. So now rationalizing means you got to multiply by radical 2 over radical 2. And when we do all that, what we get finally is negative radical 2 over 2. That is my sine theta. And then let us also figure out the cosine. That is also write the cosine theta. Guys, the cosine theta is x over r, right? It is the adjacent over the hypotenuse, and adjacent here you can think of that adjacent as the x value or x coordinates. So x is positive 1 over radical 2. Same thing, guys, we got to rationalize, and what do I get? A radical 2 over 2. I have the value for sine theta and the cosine theta. Guys, we already know that this is in the fourth quadrant. In the fourth quadrant, so what we have to do is we have to look at our unit circle, and on the unit circle we have to figure out, let me write that down here. So radical 2 over 2 and negative radical 2 over 2. So on the unit circle we can easily find out the theta for which the cosine is positive radical 2 over 2 and the sine is negative radical 2 over 2. Guys, we also know the fact that cosine is positive in the fourth quadrant and sine is negative in the fourth quadrant, so it kind of makes sense in that context as well. So if you look at your unit circle, based on these two things, you get theta equals to 315 degrees. Let me make sure that's what I have in my, yes, that is exactly what I found in my notes, which is also equivalent to 7 pi over 4 radians. Okay, guys, this is the theta. We have the r. Let us write the final form in the final polar form. So guys, the final polar form will be written like this. Z equals to, we know the polar form, we know the standard way of writing the polar or the trig form is r cosine of theta plus I sine of theta, right? So polar form or the trig form should have trig functions. Now r, we already know the value for r, we have calculated that is radical 2. So we're going to replace that r with radical 2, and then we have cosine of theta. Guys, I have to write that cosine, but theta is 315. So, or you can use the degrees or radians. Let us use radians here, 7 pi over 4, and then plus I times sine of theta. Theta is still going to be the same, I times sine of 7 pi over 4. Guys, you can use radians or you can write 315. Guys, this right here finally is my polar form or the trig form for this particular complex number. So in this example, by actually plotting it and using the basic idea of the definitions for the sine and cosine, and then looking at the unit circle, we were able to find that angle, and from that angle we were able to convert or write this complex number, which was written in the standard form, to a polar or a trig form. Okay, guys, it's not too complicated. All you have to do is you have to first plot that complex number, and from there, just by using the trig ratios and using the Pythagorean theorem and knowing how to write the polar form, one can easily convert from a standard form to the polar form. And going backwards is actually even more easier than going from a standard to the polar form. Guys, this is example 1. I'm still going to show you 3 more examples that will cover basically all the types that are there for converting from standard to polar. Okay, guys, keep practicing. I will see you next time.